So I am Dr. Sivam, co-coordinator of ATAL FDP. So this it is the lab session and it is started now. So today we will start from energy source lab. So there are some lab assistants and lab in charge. He will explain to the participant. Yes. These are the participants. Number lab. So the solar thermal and so let's start from first solar thermal division. This is here for it is convert solar into thermal. So in this is the collector. Okay, and this is the light source, artificial sun. Okay, so when the light is increasing on this collector, so there is a absorber plate, surface coated, so for more radiations. Okay, so this is the absorber plate in which the water pipes, basically the tubes, copper tubes are welded, sport welded. Okay, so this is the header, and the last to the graded losses or to okay. So when the light is on this, absorbed by the absorber plate and the water is flowing from the tank due to the gravity. Okay, when the water circulating in these pipes due to the density difference, when it is heated, it's created and the flow is created. Okay, so water is in this setup. We check the losses, the system efficiency. Okay, so there is a wind, artificial wind setup. So we can change the wind speed. Okay, so in this we can change its luminosity to according to the sun radiation higher or lower. Okay, so we check its heat removal factor, its efficiency, all the factors. Tilt angle we can change from the that side. We can change its tilt angle of the collector. Okay. So there are the two modes. First is natural phenomena, which is due to the density difference. Another is by the pump, forced circulation. We can use the pump. So we can there is a pump which is used to circulate the water from the cold water tank bottom and to the so this is the flat plate collector, non-concentrated type of collectors. There are means the area of the absorber equal to area of the, so there is this is the area of the absorber where the radiation is falling and absorber and the receiver area is same. Okay, so non-concentrated type of collector. Another one in our cycle experiment, this is the concentrating type of collector. Okay, this is a parabolic curve, line concentrator. So in concentrated type of collectors, there are two types. First is the point and the line. Means this is the reflecting surface. So it will be used here in a parabolic shape. So the coming person is focused on the line. Okay, in this pipe, this is the receiver. Okay, So the consistency means the area of the reflector is more as compared to the area of the receiver. So there is concentration. So the temperature range is higher in this category, and in the flat plate it is restricted up to 100 degrees centigrade. For in which 200 degrees centigrade we can achieve higher temperature. Okay, so there are the two uh, reflecting surface we are using here. So in this experiment we can use here water tank. We use water to heat the furnace to check its efficiency. So in another which we can use thermal. In the we heat the heat transfer fluid to check its effectiveness. Okay. So next one is solar thermal planning kit. This is basically a photovoltaic planning kit. और शेडिंग का देखने इसमें शेडिंग का यूज करने की इफेक्ट क्या पड़ेगा आईवी और पीवी का होता है ठीक है हाँ तो दिस इज द बेसिक ये फाइनल स्टाइल बोर्ड स्टाइल चल हमारा ये वाला सब इसका कोई
We can explain here series and parallel operation.
in this series
Yes, you can discuss this one.
सीरीज और पैरेलल कनेक्शन में हम लोग इसके मतलब आईवी और जो एफिशिएंसी वगैरह है सब वो एज द जो रेडिएशंस ठीक है दिस इज आवर ट्रेनिंग किट need to protect and define the value. This is the solar planning and you have to ये विंड टरबाइन का एक्सपेरिमेंटेशन हम लोग करते हैं तो ये आर्टिफिशियल इसमें आर्टिफिशियल ग्लो से हम लोग विंड को इससे क्या इफेक्ट पड़ेगा इसकी पावर पे और डिफरेंट स्पीड पे और स्पीड चैनल क्या
मैक्सिमम पावर तकनीक दूसरी करते हैं अगर विंड की मैक्सिमम पावर चाहिए
तो इस मॉडल अभी काम चल रहा है इसमें काम हो नहीं तो ये मतलब सीपी चैनल या चेंज करते हैं वो उस पे अभी काम होना बाकी है
मैक्सिमम पावर
प्रैक्टिकल करते हैं बच्चों को अभी लॉकडाउन में जो भी काम हुआ है ठीक है
Okay, sir. We will move next experiment.
नेक्स्ट
So this is another type of non-concentrated type of collector. This is evacuated tube collector. Okay. So there are the tubes, glass tubes, concentric two types of tubes, and the vacuum inside the tube. Okay. So vacuum से क्या होगा कि जो losses होंगे हमारे, मतलब कंडक्शन कन्वेक्शन से जो लॉस होगा, जो हमारे एनवायरनमेंट में लॉस होगा, तो वो उसको हम इससे बहुत कम वैक्यूम से कम करेंगे. वैक्यूम से वी कैन रिड्यूस द लॉसेस. ओके. तो दिस इज द हेडर. ठीक है. वाटर देयर इज अ टैंक, मतलब वो भी टैंक रहेगा ऊपर. ड्यू टू डेंसिटी डिफरेंस वाटर हीट होगा और वो सर्कुलेशन, देयर इज अ सर्कुलेशन फॉर्मिंग हो जाएगा इसमें. ठीक है. ये है इवैक्यूएटेड टू कलेक्टर. आपने देखा होगा ये हॉस्पिटल्स वगैरह में, कहीं भी घरों पे भी देखा है आपने. हैव यू सीन दिस बिफोर? इवैक्यूएटेड टू कलेक्टर
वाटर हीटिंग के लिए.
वाटर हीटिंग. सो बेसिकली डिफरेंस जो फ्लैट प्लेट कलेक्टर हमने नीचे बात की है उसमें और इसमें क्या है कि इसमें एफिशिएंसी सिस्टम की ज्यादा रहेगी. इसमें 50 to 60% एफिशिएंसी इस सिस्टम की रहेगी फॉर वाटर हीटिंग, और हम 100 डिग्री तक का टेम्परेचर इससे अचीव कर सकते हैं इस सिस्टम से. इवैक्यूएटेड कलेक्टर. ठीक है. ये है, ये भी एक नॉन कंसंट्रेटिव टाइप ऑफ कलेक्टर. दिस इज आल्सो नॉन कंसंट्रेटिव बिकॉज द एरिया ऑफ द receiving and the area of the reflection is same. Okay. So let's move to the concentric, another type of concentric type of collector.
If you have some question, you can ask.
Yes, this is the concentrated type of collector. It's called shuffler reflector. Shuffler. Okay. So it is one axis tracking. When the sun is rising from the east or to the west, so we can track it single axis tracking. Okay. The duration increasing on this glass reflecting surface are reflected to the focus. There will be some distance from the reflecting surface. Okay. All the radiation are reflected to the focus. We can use it for water heating, for cooking, for drying, for various purposes. Our institute won 3 lakh cash prize on this setup organized by ONGC Solar Chula Challenge. Okay. This is also a type of shuffler reflector. This is standing type of reflector and it is laying type of reflector. This is all solar collector for convert solar energy into thermal energy for heat energy. Okay. Shuffler reflector. Subhash, display चलो. तो काम करा भी करा. थोड़ा ऊपर कर दो अंकल, ऊपर कर दो. बस बस थोड़ा नीचे कर दे. बस. वो निकला प्लीज. Come fast. और पीछे कर. पीछे कर थोड़ी पीछे करना. बस छोड़ दे. So this is our parabolic dish point type of concentrator. You can check all the radiation impinging on this surface are reflected to the receiver. This is the receiver. So there is a high concentration of radiation, reflected radiations are there, so high temperature are achieved at this point. Okay, this is called parabolic dish concentrator. You can you आपने पढ़ा होगा Parabola, have you studied parabola?
Yeah.
So parabolic focus one. Okay, all the radiation are focused on this focus point. Okay,
Yeah.
this is the parabolic high concentration polar thermal collector. What is the value of concentration? 100 to 125. और इसकी 1500 तक हो सकती है. 25. Yeah, 30 to 40.
If you have any question, you can ask here.
Man. Now it's manual, but we can use automatic.
What is the heating temperature?
Now its temperature is 700 degrees centigrade.
700.
Maximum 1100 degree centigrade we are achieved by this system. Like the structure. In summer.
1100.
I am working on this setup. Okay. Any doubts?
तो नॉर्मल रेडिएशन आ रही है ना इसके ऊपर, वो सारी
Parabolic disk concentration.
वहां पे हो रही है, वहां पे जैसे आग लग रही थी ना, फायर हो रही थी ना, वो लकड़ी.
So it is made by our team also. It's not fabricated from outside. We have made in our lab. This system, हाँ कर सकते हैं, इलेक्ट्रिसिटी भी जनरेट कर सकते हैं इससे. पीछे ये थर्मोकपल्स वगैरह है ना, हाँ, टू नोट द टेम्परेचर्स, थर्मोकपल वगैरह है. अभी हम इसको कुकिंग के लिए यूज कर रहे हैं सिस्टम को. ये सेटअप हमने यूटिलाइज किया फॉर कुकिंग पर्पस. देयर इज ए heat transfer fluid which is rotated by the pump in this receiver. Okay, we are using for.
आप जाइए वहाँ इसको ऑन कर जो सिस्टम कर सकते. एक सर हो जाएगा. आप खाली खोलिए, नितेश जाएंगे साथ में.
लेके चलेंगे ना ये साथ साथ में.
सही. इस सिस्टम यही से ऑन रहेगा.
So it will not stick. How do you regulate 200? Regulate? It depends on the radiation. Here.
बंद हो गया.
From in the morning when you start the system, so it will go to highest to 200. Add
चेक करिए.
we have to look like we want to cook the food at 100 degrees centigrade. Okay, so when we put the food in this, so it will not go fast. Is to 200. It will start from the ambient temperature to start on my time लगेगा. It will take time to reach 100 degrees centigrade. So it will when we water here. Okay. And the temperature is 200 degrees centigrade of the system. Now it is the oil temperature is 200 degrees centigrade. Okay. When we put the water at the ambient normal water, we put it this for cooking purpose. So it will take time to absorb the heat by conduction, convection. Okay. So it will take around 10-15 minutes to reach at 100 degrees centigrade. To boil, it will take time. It will not. We can use regulate in this system. Regulating for particular application, it is very difficult in this system because the temperature depends upon the solar radiation which we get from the sun. Okay. So for like in LPG, there is a regulator to regulate it. Okay. We have to depend on solar radiation. हाँ रोटी for roटी making it will require 350 to 400 degrees centigrade. आवाज नहीं आ रही बैटरी है if you want higher than 100 degrees centigrade, so regulating is a difficult type for this system. Okay.
we have to maintain constant
वही बात हो रही वो पूछ रहे हैं कि हाँ मतलब ये है कि वो पूछ रहे हैं कि रेगुलेटिंग अगर हमें सोई रखना है टेम्परेचर तो कैसे जैसे मतलब एलपीजी स्टोव लेके होता है हमारा हम उसको हमने रेगुलेटर से उसको लेकिन इसमें सिस्टम में क्या है जो रेडिएशन आ रही है हाँ उसके अकॉर्डिंग टेम्परेचर इसका फिक्स रहेगा ठीक है ना regulation because we have to depend on solar intensity which we get then so it's a difficult हो गया ठीक हाँ So, what's your question?
My question is for the non-concentrated tank to store the hot water.
Yes. So it will just say this is the collector, non-concentrating. This is also non-concentrated collector. First. यूज नहीं कर रहे हैं इसको ढक कर देते हैं अभी काम नहीं कर रहे ना ये भी निकाल विकास ये खोल देख के आराम से खोलिए ठीक है ये भी नॉन कंसंट्रेटिव कलेक्टर नॉन कंसंट्रेटिव टाइप ऑफ कलेक्टर ओके वो कंसंट्रेटिव टाइप है सर हाँ सो तो make a circulation phenomena. The tank is placed above the collector. Okay, so this is the tank. This is placed above the collector. Okay, so due to the gravity, due to the temperature difference, density difference, the circulation is formed. Okay, so तो चलो अलग system है. So there is a tank above this system, above the okay, and they are connected with the pipes. So all the phenomena is created due to the density. So is it the cold water? Now this is for another application. This is the oil tank. This is used for air heating purpose. This is set up by this Mr. Anshul. Anshul, please explain. Actually, this is the evacuated tube. This is the sun. This is an insulated tank. It is used to heat transfer fluid in the solar collector. The fluid is filled into this tank, and the fluid is circulated in a closed loop using this gear pump. And we get hot fluid STF at a temperature about 150 degree or 160 degrees Celsius at the outlet, and we can use this fluid for any heating application like solar water heating application, solar air heating application, solar drying application, using any suitable heating system. So we are using this for air conditioning purpose. You can also use it for any
सपोर्ट नहीं कर रहा है सर
So this series in parallel.
No, these are in series. They are
हाँ भाई मुन्ना
नहीं ऑन कर ली
तू भी बता यार कौन के सारा तेरी है
the fluid will from this point that's the hot. What is the material? Hello. हाँ हाँ हेलो आवाज कम ये लगा ऊपर से दबा अब मेरे में आवाज थोड़ी आ रहा है ये लगा सुन वो लगा लीजिए ना सर
So it provides thermal insulation. So temperature of more than 160 Celsius is achieved under that. More than 160. It depends on the solar radiation. How the solar radiation में 130 on an average 130 Celsius. And we can use what we it requires it should have a high specific heat. So high specific heat capacity. It should its flash point should be high, so it doesn't touch. And it's like it's a vaporization temperature. We want to see an individual. So does the जब हमने जब हमारी रिक्वायरमेंट तो दिस इज द जस्ट there are the two tubes, glass tubes, okay, and the vacuum inside the tube. 0.05 glass tube. These are two concentric coaxial glass tubes. Outer tube is transparent and inner tube is coated with a special selective coating of aluminum nitride. And both the tubes are fused together, creating a vacuum between the tubes. The vacuum is less than or equal to 0.05 Celsius. So the inner tube absorbs the solar radiation that falls on this tube. And the vacuum between the tubes serves as thermal insulation, which prevents the heat losses. So a temperature of more than 150-160 degrees Celsius is maintained. We can use it for any heating purpose, like water heating.
Okay.
In this setup, and it will change after that. Yeah. Tubes are available in the market of different sizes, different diameters. This is of small diameter. This tube has been used there.
सर अगर इसमें वैक्यूम है बीच में तो हीटिंग जैसे आ रही है रेडिएशन जो भी आ रहा है तो एब्जॉर्ब कैसे करेगा ऑलरेडी वैक्यूम क्लियर है
वैक्यूम की इसके अंदर यहाँ लगा
दिख रहा है
बराबर है
हाँ ये अभी दिख रहा है तो वैक्यूम
नहीं यहाँ लगा
नहीं तो हाउ इज इट पॉसिबल
ये
रेडिएशन विदाउट मीडियम क्योंकि वैक्यूम इज जस्ट एम्प्टी है ना देयर इज नो एयर
यू कैन चेक
जो हमें हीट मिलता है रेडिएशन को एब्सॉर्ब करके वो हीट क्रिएट
करते हैं इसमें
हाँ
फिर we have to fill water
या एनी फ्लूइड यू कैन यूज वाटर और यू कैन ट्रांसफर फ्लूइड जो भी रेडिएशन से सेलेक्टिव कोटिंग रेडिएशन को एब्सॉर्ब करके हीट में कन्वर्ट कर रही है डायरेक्टली टेम्परेचर को नहीं कर रही अगर ये ट्यूब बाहर वाली टूट जाती है वैक्यूम लाइक पंक्चर हो जाता है तो ट्यूब वेस्ट है फिर उसके बाद किसी काम के लिए
These are the PV collectors. By photovoltaic the solar radiation converted to the electrical radiation. So when the radiation is falling, this plate converts the radiation energy into the electrical energy. These are called the fingers for collecting the current in a particular manner. We can arrange according to the in series manner or parallel manner for raising the current level or voltage level. And all these fingers are collected at one side by a common wire. This common wire is also put to the outside for collecting the voltage and current to the load. So we can change the layout of the system by changing the tilt angle, that is the beta. For example, if radiation is falling according to 30 degrees, we can change beta to 30 degrees so that the falling of the radiation is likely to be directly incident on this plate, so that it can collect maximum amount of the radiation. So the amount of radiation depends upon the amount of radiation the amount of electricity is produced. So basically these are made from the cohesion of germanium silicon ions and
in this system में हम क्या कर रहे हैं, हमारा जो
मोनो होगा सर, पोर्लिक में तो ना डिजाइन चमकते हैं ना, इतने से मोनो सिलिकॉन सोलर
दबाओ इसको। ओके, इसको दबाओ।
इसमें क्या कर रहे हैं हम, कंपैरिजन मतलब जो एग्जिस्टिंग पीवी मॉड्यूल है, ठीक है, उसकी परफॉर्मेंस को इस सिस्टम के साथ हम लोग कैसे उसकी एफिशिएंसी को बढ़ा सकते हैं, उसका एक्सपेरिमेंटेशन का सेटअप है। ठीक है, इसमें क्या है, ये रिफ्लेक्टर सरफेस so these are the aluminum reflector, okay, to concentrate the radiation to this panel. Okay, so we compare the performance of this system to the existing system, same time the same power. Okay, so the power get by this system is more by using this type of reflector. Okay, so when it is, because it the panel is the temperature, I think 45 degrees centigrade is required for better working for this system. Okay, so for cooling purpose there is the nozzle. Okay, so it is when the temperature of this panel goes above from the 45, so it will the water water is automatically maintain the temperature, to maintain the temperature. ठीक है, इसकी सिस्टम की एफिशिएंसी को हम एग्जिस्टिंग सिस्टम की एफिशिएंसी से जब कंपेयर करते हैं तो इसकी एफिशिएंसी 8 to 13%, 8 से 13% इसकी सिस्टम की एफिशिएंसी हमें ज्यादा मिली है। ओके ओके, यू कैन चेक आवर पेपर ऑन दिस प्रोजेक्ट, गूगल स्कॉलर फॉर दिस सिस्टम। ओके, इस सिलिकॉन जो भी आपका मार्केट में अवेलेबल है, एग्जिस्टिंग सिस्टम पे हमने इस सिस्टम पे कमर्शियल पे जैसे हमारे वो सेटअप लगे हैं ना, हाँ, उस सेम पैनल को हमने यूज करके इस सिस्टम की एफिशिएंसी को, जो हमारे स्कॉलर हैं इस पे काम कर रहे हैं, अमन शर्मा, उन्होंने इस पे एफिशिएंसी को इंप्रूव किया है बाय दिस सिस्टम। पहले उन्होंने ग्लास लगाया था यहाँ पे, अब ये रिफ्लेक्टर सीट लगा रहे हैं, उस पे काम कर रहे हैं। ओके, ठीक है।
एल्युमिनियम रिफ्लेक्टर बेटर
10% इससे ज्यादा रहेगी
हो सकता है।
पावर जो पैनल पे डिपेंड करेगा ना, पैनल की
ऐसे करके ऐसे जाएगा
पावर जनरेशन।
what is the geometry of reflection?
some angles रहेंगे कुछ उस पे angles पे हम rotate
Actually, the power density decreases as the temperature rises. So to cool down the purpose, so there is a cooling purpose for entire system, so that the temperature should be maintained within the limit. So to limit the temperature, we can raise the efficiency of the system. So we have to maintain the below the 30 degrees centigrade, ideally 50 degrees centigrade for a PV collector. So by circulating the fluids like water, air, etc., we can raise the efficiency of this overall system. So the basic purpose for cooling is that to maintain the temperature limit of the system.
But amount of radiation increase हो जाएंगे reflection से. Due to reflection, there are some radiations because the it work as a concentration because the area is increasing of the radiations. Okay. ठीक है. तो जैसे मतलब इसको कुछ एंगल पे हम रखे डिफरेंट एंगल 5 डिग्री 10 डिग्री पे हमने टेस्ट किया है. यहाँ से भी हम इसको ऊपर कर सकते हैं. सिस्टम इज को भी हम ऊपर तक हाँ रिफ्लेक्टर है. ये रिफ्लेक्टर हम यहाँ से भी सिस्टम को मतलब कुछ एंगल्स पे रख के हमने काम किया है इसको. बेसिकली हम दोनों हाँ तो डिपेंड करेगा कि एंगल्स कितने रखने हैं क्या रखने हैं वो स्टडी पे डिपेंड.
क्वेश्चन है ये क्वेश्चन.
I'm trying to imagine a situation. Maybe when the sun is setting, wouldn't these trees maybe cause some shading on the
shading?
banner?
No, these trees? No shading.
Okay, sir, for me, if the purpose of this one is to reflect heat in this one, why you do use the sun direct?
Why we use
the sun direct? Why we use this instead of the sun direct?
Because we if we use
because the direction of sun is not always inclined on the surface. So we have to try to incline the solar radiation directly on the surface. For this purpose, we have used this type of reflector in such a manner that in always time the radiation of the sun is on just an inclined position on the surface, so that the efficiency of the system can be increased.
Please, is this the natural position of this reflector, or you can tilt it?
yes
Yes,
You can tilt it based on the direction of the
there
sun.
is two types of orientation. First, we can change this type of orientation, or secondly, of this. So it is convenient to change this orientation,
Okay.
particularly for this.
जैसे सन मूव करेगा ना जैसे मतलब if the direction of the sun is there तो इसकी जो पावर जो इस पे रिफ्लेक्ट होकर रेडिएशंस आएंगी ना वो कभी यहाँ आएंगी कभी यहाँ आएंगी कभी यहाँ आएंगी. So pattern is different. We not rotating this to according to the sun.
This reflector is also kept up. इसको ऊपर किया जाता है. इसमें जो रेडिएशन आती है ऊपर जाती है. And that reflector works as secondary radiation.
Okay.
Reflects the radiation from the
So the sun hits this one, comes here, and then comes
First
here.
is this one.
प्राइमरी एंड सेकेंडरी
इसकी स्पेक्ट्रम है उसकी प्रोफाइल यहाँ आएगी और इसकी प्रोफाइल यहाँ आएगी मतलब डिफरेंट करेगी. जैसे सन वहाँ है तो कभी कभी अलग-अलग पॉइंट हाँ अलग-अलग पॉइंट पे अलग-अलग साल का अलग-अलग आएगा. डिफरेंट साल का नहीं हम कर रहे हैं अलग-अलग साल का कर रहे हैं हम पूरे सिस्टम का
देवेंद्र पता नहीं
ठीक है.
चलो बंद कर दो. वीडियो ऑफ कर दो. ऑडियो बस ऑडियो ऑफ कर दो. बोल देते हैं ना उनमें बोल दीजिए कि 2 मिनट में.
सर भी
Individually, I want to
हमारी टीम ने बनाया है सभी रिफ्लेक्टर लगे हुए हैं.
फोटो ले लो अभी.
फोटो ले लो मेरा. मैंने बना दिया. चाचा ने
मेरे मन में भी वही अभी सोच रहा हूँ.
अच्छा मेरे लिए
वो स्वीट बहुत स्वीट है ना. सभी के स्वीट है.
इसलिए तो मैंने दे दिया गुलाब.
गुलाब जो दे दिया
हमने
अभी गुलाब
Am I audible? Okay, sir. Hello, am I? So this is microgrid, hybrid microgrid. Yes, this is the setup. Okay, this is the setup, and we can see here. And this experiment we will perform today, and all participants will be attend, and they can ask some question if they are interested. Okay, so we can wait, see one by one.
This system consists, for example, it is the wind emulator. It is photovoltaic emulator. Is the this and this is the hydrogen. PM based means proton action emulator. Is the type of the fuel cell. All the systems are energy producing system. These produces the AC and both these and the system, that is the photovoltaic and the fuel cell, producing the DC system. All these are connected at a common coupling called DC link capacitor. First of all, the wind turbine emulator mimics the behavior of the actual turbine. That is the actual behavior of the system. So, in the wind turbine is separately controlled. This is the field control. That is, the speed of this motor can be controlled by changing the amount of the current of the fuel. Changing the amount of the current, we can control the speed of this DC motor. This DC motor is directly coupled to the speed of DC motor is very rapid. And the speed of the DC motor can control the speed of the generator. So when generator will move, so by pressing the my DC link is directly coupled for the So first of all, the output of this PMSC generator is rectified. This rectification is uncontrolled. That is the input. That will be accordingly the output. The output of this generator, that is the rectified output, which is the DC output, is connected at the DC link capacitor. And the same side, the output of this photovoltaic generator is also connected to the receiving side, and also fuel cell is connected to the receiving side. All three these are the major energy producing elements. And along with these elements, there is a battery energy storage system, which is also coupled to the DC link capacitor. This battery is a lithium-ion type battery. This lithium-ion battery, yes, is for charging discharging purpose. That is to ensure the phenomena of the charging discharging. Then there is excess power which is produced, we can store. And where there is a need of the power, we can take it from this side. So all these elements are connected to, as said earlier, common coupling point capacitor is connected to the side of the 3-gauge 6-water is coupled to the delta star transformer. Delta is from the inverter side and star is from the load side. The transformer is coupled to grid system or the load system. So we can use this AC/DC microgrid directly connected to the grid without grid system. That is so when connected to the grid system, the frequency is synchronized with the help of the phase log loop, and when there is no grid side connected, that is directly coupled to the load, we can maintain the frequency of the inverter by the PWM. So along this side, there is 4 converters. There is one buck converter for the wind turbine emulator, one boost converter for the photovoltaic, one boost converter for the fuel cell, and there is one bidirectional buck boost converter for the battery energy storage system to ensure the charging discharging phenomena simultaneously. All these entire system, the controlling of this entire system is platform on the gravity environment. So by controlling the input according to the users, we can control the input output of all these elements. That is, the power flow of all the elements can be controlled by controlling the gravity input. Right? The converter is controlled according to duty cycle. Duty cycle can be modified according to the inputs. All the user inputs are connected at the FPGA connected dialing start. This dialing start is coded to the very low system according to the utility based system. So these are already coded. So by modification of the duty cycle, the power converter can be modified. So if we change the duty cycle ratio, we can change the voltage level of the elements, or accordingly we can get the power. So
maximum
2 kilowatt. The capacity of this wind turbine generator is 1 kilowatt, and for fuel cell it is 1 kilowatt. The battery system is also for 1 kilowatt. So overall productivity is of 4 kilowatt, but this system has some limitations. So that we can generate up to 2 kilowatt.
बैटरी सॉफ्टवेयर पे काम करता है. Fuel system can generate 1 kilowatt. What is the voltage of this feature?
It is the 46 to 48 volt DC before converter. So by after conversion, it is synchronized to the level of the grid level. That is the 150 volt voltage is injected to the inverter, and it is further rises to the level of the grid. That is 220 the single phase and 420 for the three phase. Super capacitor. Yes. So we have two types of energy storage system. One is the lithium-ion battery, and second is the super capacitor. It is all energy device like battery, but it is very fast responding compared to the battery system. For example, if a battery responded in 10 microseconds, then this supercapacitor will respond to the system to 2 microseconds. So if there is a slow responding system, like for wind turbine emulator, like photovoltaic, and we are connected to the for very continuous capacity is required. So we must have attached some fast responding systems like supercapacitor or like battery. So the combination of supercapacitor and battery of these systems makes it more reliable and electricity regulations. So like compared to battery, much more fast responding. Super capacitor and so forth. It can charge or discharge like that of battery. Yes. Both fast. Both are fast. Life of the system is about 10 years. Batteries also depends upon the charging discharging cycles. When there is time passes, so there is much time for charge and discharge. Cost is not much comparable. It is slightly high compared to the battery systems. Yes, yes. Compared to the it is happy. And what is the rate of no. It is a time. Wait. It is our time. Consumptions and is similar to the battery system, but much more fast respondents compared to the battery system. It can also charge and discharge. It can consume the power and deliver the power.
भाग जाता है.
You know about the capacity? Yes, charges.
लेना है क्या ले लिया लिखा हुआ है नीचे
उधर खींच लीजिए उसको पीछे बनता है, लेकिन थोड़ा उसका अलग इंटरफेस है, इंटरफेस अलग है, मैथमेटिकल है ना। आवाज आ रही है, इसका वीडियो चल रहा है। डाटा के लिए रहेगा। पेन हुए दो पेन
फिर वो पहले फिर वो कर देना
वायरलेस स्पीकर
तो मेरे पास भी
इसको पकड़िए सर उसको कुछ नहीं करना सर कहते हैं
You can sit down, na, everybody.
वो पानी पीने को गए
अपने काम में तो इसका यूज कर नहीं सकते मेरे वाले काम में इसका यूज होगा ही नहीं
हमारा तो नहीं है हमारा का तो बड़ा बड़ा डेटा सेंटर्स खोलना है बस
एक पेपर में काम कर रहा हूँ
वो सॉफ्टवेयर का आता है ना रियल टाइम ई टैप या रियल टाइम सिमुलेटर नहीं वो तो ऑनलाइन हाँ और कुछ ये मनी का रिलेटेड सॉफ्टवेयर चाहिए कितना पैसे रियल टाइम है कितना पैसे है
एक वो है एक जो बैट लेवर गेम्स पे काम करता है हाँ एक है हाँ उसका एक बार बताया ना मैंने सर उसका नाम भी याद नहीं आ रहा क्या
नहीं बैठे क्या हाँ हाँ बैठे हैं दोपहर को आया हाँ कौन संजय अभी तो नहीं है अभी सेकंड रिव्यू में है ना
वहां तक पहुंच गया तो हो जाएगा
तुम्हारा किस में आया सर
नाम बोलिए जनरल ऑफ ऑटोमेशन एंड पावर इंजीनियरिंग
कौन सा है ये? हाँ?
आप जो बोल रहे हैं यहाँ सारी से ठीक है सर। यही आवाज बोलने वाला कहाँ है सर? बोल तो गए कुछ बोल हमारी आवाज नहीं हमारी आवाज नहीं आ हम लोग जो बोल रहे हैं वो जा रहा है वो नहीं
Any question?
So this experiment is going on, and related to this manual we will share.
सर वो नहीं हुआ। दोनों 40 इसके लिए 40
रिकॉर्डिंग कर लेते जल्दी, खुद ही कर लेंगे, चलने दीजिए। आवाज नहीं आएगा ना, यहाँ पे बोलेंगे सर तो आवाज आएगा। रहेंगे कोई रिकॉर्डिंग हो रहा है।
कनेक्टिंग टू ऑडियो, अभी कनेक्टिंग नेट नहीं दिखता है, कनेक्टिंग कनेक्टिंग टू ऑडियो
नहीं चल रहा है, ठीक है जो है ही नहीं हम लोग। अभी ऑन हो जाओ ना, इसमें देखो विंड टरबाइन रिकॉर्डिंग हो रहा है।
गूगल पे भी कर दिए थे, गूगल पे 120 गूगल पे भी रिकॉर्डिंग किए थे, लाइव किए थे, यूट्यूब पे दे
बंद हो गया ना, बंद
बंद हो गया, लाइट गया था।
तो यहाँ नहीं दिखा रहा है ना लाइव। कोई बात नहीं, इसी को लिंक कर रहा है। पहले हम इन्वर्टर ऑन करेंगे ना। ये 500 आरपीएम से ज्यादा नहीं है, 500 के आसपास ही मिलेगा। Light. आ रहा हूँ नीचे आ रहा हूँ जल्दी से खत्म करो हाँ जी आ जाइए बैठ जाइए फॉलो बताएंगे सर यस फ्रॉम दिस साइड सर विल एक्सप्लेन got the idea about structure of the setup. So how this setup operates? This setup can be operated if grid connected or connected to the grid or in isolated mode. But right now we will show you only grid connected mode because in isolated mode we have to balance generation and consumption. So we need proper calculations what power is required from that generator or that generator. Okay, so we need proper calculation for that. We don't have it right now. We will show you the demo how it can be operated in a grid connected. Same operation will be valid for isolated. So we have to connect a grid. So this is suppose our this setup is having a DC link. This all is connected to a bus at a DC link. So this needs to be synchronized. So we will give the reference voltage here. This is our 120 volt reference voltage from the grid, and we will turn it on. Battery will help us in synchronizing and maintaining the. Now inverter is turned on. Now we will turn on the battery. Turn on this setup also. Battery off. So we will start the setup. Currently it is at 88 volts. You can see the capacitor voltage here. And this is the VDC. So we will turn on the inverter. Now this will try to maintain at 120 volts. Now this is connected. Our system is connected to the grid. Now we will turn on the generator. You have different modes of operation in this domain and PPT also. This is the automatic mode, right? Whatever you will turn it on this panel, the light. Like I have turned on the wind generator. So WPV and dividend into PPT. If I want manual operation or some other kind of operation, then I can also do it. I want to have a power electronic so I can change the duty ratio of my converter from this. I can turn it on and turn the heat from this side. Okay. So whatever duty I will set, that will be set from this point. I can also
I can see the readings of my control here. Basically, it is a PMSG. So at the back end, you have a DC motor. So this armature voltage and this field voltage, this is for the DC generator. We are controlling the speed of DC generator, and we are controlling the operation of the PMSG. So I have turned it on 4. I will increase the speed. Now this WT is on. We have to turn on the PV there also. So the correct settings there. 9600. Okay, so all this is correct. So I will turn it on. So you can see the voltage change there. It came out to be 39.9. Now this is not connected to the grid. This in isolated mode. I have to turn it on from this panel. I will turn it on from this side. WMPD. Okay, so now it is connected to the DC bus. It is connected to the DC bus and it is in automatic mode. WMPD. Okay, I can do it through manual also. I will turn on this switch and change the duty rate. Whatever duty ratio I want, I can set it. If I don't want the automatic setting to follow. Now our MPPT is on. Now we will start the battery. We have to turn on the switch. The battery is on. So battery switch is on. Now I can either charge or discharge this battery. Okay, so that is on me that what I want to do. If I want to charge my battery, I will increase the reference current. So you see, when I started the charging operation, this green light switched from battery boost to battery bus. Okay, so that means power is coming from the grid to the battery. Okay, so this is turned on. Now, if I will remove it and then I will start discharging. So battery boost is on. Now battery is supplying. So battery is discharging. Battery is supplying the grid. Okay, now this fuel cell. We have same procedure we have to follow for the fuel cell, but in case of fuel cell, you have to be careful because the response of fuel cell is very slow. So suppose I turn it on and I increase the reference current that this the fuel cell has to provide. This is going to increase at a very slow rate. Suppose I change it to 0.5. Now you see this is going to take a large time to increase. This is currently 0.03. Yes, so it's going to take some time. Voltage buildup is going on in that setup, so it is going to take some time. 0.03 to 0.04. 0.05 is going to take some time. So this time, for that time, you have to wait. Otherwise, this setup is not injecting power into the grid. Right now, it's working to increase this fuel cell current. We will wait for some time. Now it changed to 0.04. Yeah, now it will increase slowly. So while operating this fuel cell, you have to be slow. So fuel cell is there for giving you a feeling of future source, but it is a very slow. Response time of this setup is very slow. In comparison to PV or wind, this fuel cell is very slow in terms of its response. So you cannot rely simply on this for your meeting of this load. So we will let it work. So now you see it changed from 0.05 to 0.06, 6 to 7. Slowly it's going to increase. Now in case of supercapacitor, suppose there is some sudden change of load in the grid. This fuel cell cannot meet that sudden change. For that purpose, we have capacitor charges or discharges very quickly. So the response time of this supercapacitor is very fast. So now we turned on the supercapacitor from that side. Now I will turn it on from here. Okay. And I can either charge or discharge this from this end. So if suppose I want it to charge. So you see SC buck is on. SC buck means supercapacitor buck. So power is coming from the grid and you see the current has turned negative. That means this supercapacitor is started charging. You will slowly see that the voltage is going to build up. Voltage will build up, will take place. Same thing will happen if I will start this discharging process. This light will turn from SC buck to SC boost, and I will see that the voltage will increase. Okay? We have, while using this supercapacitor, you have to maintain some voltage on that system. Otherwise, you may face problem operating the supercapacitor. Okay. So like this, now we have turned on everything. So you, this is now this setup is feeding power into the grid. Okay. This setup is feeding power into the grid at 120. We have not connected these loads because these loads are for isolated system. Grid means it's having generation also and load also. So the load is there. You are taking power from the grid and you're running these operations, generating something, and then again re-injecting power into that. Okay, so this kind of a setup is this. Okay. Any questions? This is just the setup. So this is just how this setup runs. So it's a LabVIEW interface, so you can run it to LabVIEW. But more better analysis you can do if you have proper operating condition. Means what at what wind speed your generator should run, at what irradiance your solar PV is going to operate, or what whatever things you have, you should, if you have proper conditions of operation, you will better understand. Okay, so this is how this setup operates. Taking gas, so reaction is taking place. That's why this is slow. Slow is forming. Hydrogen and oxygen are mixing inside. So that's why this is slow. This you see the black thing. This is the membrane, and this is the reaction. The voltage is building slowly. That's why. Full charging. Yeah, we have not tried this for full charging. It will depend on your reference current. What reference current? Suppose I set it at minus 0.2, then it's going to take some time. But if I suppose increase it to say minus 2 ampere, then the time.
Anyone can ask any question?
On that you have missed your on back end. You can create and go in the back end. Control system. Yeah, like for solar they have. Wind, I don't know the name. I can see. You want to change that algorithm, you can come back and make the log zero. What is the voltage of supercapacitor? With a supercapacitor 1780 volt. Yeah, this voltage dropped down very rapidly. Okay. It is just for we not connected or connected all the time. Whenever there is current in the but the grid is not drop in the voltage. Then it's turned on and it's double.
So we want to close here. So this experiment is almost discussed. So he is Dr. Pradeep sir. He is the faculty in charge, professor in charge of this lab. So he explained everything. So right now time is over, more than 4. So I want to close here. Thank you. Thank you to everyone.